I have a second channel, Cube Compium TDX.
Hey everybody, in the quest to find some cells to retire some of my worn out 18650s I use for powering my cameras, here is yet another laptop battery out of my collection. I've gone through, two Dell laptop battery packs and two Toshiba laptop battery packs. One pack had a set of real cheap Chinese cells that were in really bad condition, corroded actually. One pack that had Sanyos in it that got hot under charge. One pack that had Panasonic cells in it that got hot under charge. And another pack, the second Toshiba pack, had Panasonic cells in it that got hot when charging and had very low capacity. So, needless to say, I got quite a bunch of 18650s up here I gotta take to the recycling center soon. We're gonna crack this pack open and see what we have. So according to the pack, it says cell origin Korea. So that would tell me we likely have either LG Chem or Samsung in this pack. And we're gonna find out here in a moment what exactly we have. So the pack, let me see if I can find here. So 52 watt hours. So we probably have some somewhat decent cells in here, provided they're good cells. Let's see if peeling this back reveals anything. It does not. So we're going to have to go head first into this thing. And this will be a little bit of a challenge because this will be my first time cracking open one of these. So let's go and get started. And of course, if this is your first time ever watching a video about how to harvest cells out of a laptop battery, I would suggest having a look out around the internet in regards to a good tutorial. Some of my older videos, I think I do talk about it a bit. This more or less a safety aspect, things you gotta watch out for, that kind of stuff. I would suggest that you research this very carefully before you ever start harvesting cells, because lithium-ion batteries, they can be dangerous if you don't know what you're doing. So let's see if we can get into this thing. Some of these packs are just really well constructed, and you'll find it can be very difficult to get into them. Sometimes you have to sit and think for a minute on how to best attack the pack. Because like I mentioned, these things, sometimes they're built super well. Looks like we might have LG cells in here. They're blue. Generally, I don't like starting on the positive side of the whole pack, but that was the side I managed to get to breach first, so Just having to make do with it. Correction, these are actually Samsung cells. I have peeled up enough of this plastic to reveal Samsung printed on one of the cells here. Yep, there you have it, Samsung. So we'll see how these turn out. Okay guys, so in this pack here, I'll show you something. So we have this conductor running from the back of the pack up through here, and we have this balance connection right there. If these two cross, these two cells will short out. So you gotta be careful to not accidentally bridge connections. Now, of course, these are insulated with the equivalent of Kevlar tape, but it wouldn't take much for your pliers to jump that if they were to actually make it through that. So you just gotta kind of watch what you're doing with these things. Just take it easy. Don't rush yourself. Keyword: don't rush yourself. I see some people on YouTube tearing these things apart and just absolutely rushing through it. Like, what's the hurry? Slow down. before you cause some problems. So we're almost into this one. We don't like much at all. Just trying to locate the circuit board in this one is in kind of an odd placement. Okay, I can finally see it for the first time now. And just like that, it popped off. Alright, so let's try to lift this out of here. And usually they have these things held in with double-sided tape, which makes it, of course, a lot more difficult to get the cells out. I mean, they build these things really well. Most of them, anyway. Obviously, the manufacturer never intended on a hobbyist or electronics guy ever trying to hack into one of these, rip the cells out. Well, we have to admit, at some point, somebody would probably be dismantling them to recycle them. So, and of course, that's true. But yep, we got some double-sided tape in here. And just easy does it. Okay, so now the battery pack has been dismantled. Of course, the plastic casing is completely off of it. And this is what I was talking about right here. So, this manufacturer, whoever built the packs for HP, they use metal strips as conductors. So you gotta be particularly careful with these. So what we'll go ahead and do is we'll first need to remove the circuit board from the pack. We have to remove this thermistor. This monitors the temperature of the pack. Now this one's still here. I'm not sure if that's corrosion or what, but we'll have to have a close look at that. And I should emphasize that it's pretty typical to when you're cracking open laptop batteries, there's a good chance you're not going to have a 100% success rate at harvesting cells. So what I'm doing now is I'm just removing tape. Little by little. Okay, so I'm going to go ahead and start up my soldering iron. Some of these packs you will need a soldering iron to dismantle, or at least it would be recommended to have a soldering iron. So what we gotta do now is disconnect these different connections on here. We'll start out with the rear. And work our way forward. And it's removing the tape that holds all this together. And I should emphasize again, keep a close watch on what you're doing, because these, of course, the batteries are energized. Okay, so first thing is we'll break the connection from the far back. And of course you don't want to keep your soldering iron on, you don't want to keep the soldering iron on there for very long. They should come loose pretty quickly. And when you're doing this, you'll be careful to make sure you don't get any loose bits of solder anywhere near the positives of these cells. Because of course that's where positive and negative meet. They meet under a insulating washer. Okay. So at this point we are done with the soldering iron. We've disconnected the circuit board. And now it's time to go ahead and test the cells. Okay, so first thing we'll do is we're going to test the voltage of the cells with the pack still together. We'll start out with the total pack voltage. Nominal voltage for this would be 10.8 volts or 11.1 volts, whether you consider it 3.6 volt cells or 3.7 volt cells. We're getting absolutely nothing, which could mean that we might have an open CID somewhere. The first set of cells are at 3.8 volts. The second set of cells, absolute zero. Third set, 3.83. So the center two cells, the current interrupting devices, or CIDs, have popped on them, which means the cell pressure has reached a certain extent. The cells may have short-circuited, or something else could have happened to them to cause them to fail enough to trip their protective devices. So with a tripped CID, power cannot pass through the cell. So the center cells we know are bad, both of them, because apparently the CIDs have tripped in both of them. So now what we can do is we can take this tape loose and we can start dismantling the cells. And these are 2400 milliamp hour cells, by the way. So pretty nice score, provided they work. So that's the thing, is provided they work. And once you have the tape removed, you'll be able to unbundle the pack pretty easily. Yeah, this cell up here looks like it may have vented. Yeah, of course, a lot of times when you look up lithium-ion cell failure, you'll get a lot of stuff up talking about cell explosions. And well, yeah, these things can explode. A lot of things can explode too, though. While these cells can go violently, most of the time they don't. They go peacefully. And that's how you want them to go, is peacefully. And you can see we're unraveling the pack pretty easily. And I have a feeling the strips on these will probably come apart pretty easily too. And just as a tip, if you are wanting to build, for example, if you're wanting to construct a power bank using like a power bank kit that has two cells in parallel, it wouldn't be a bad idea to save these tabs, keep the two cells together. You could actually test them in a like an overdischarger together if you really wanted to. Because, for example, some of DIY power bank kits from eBay out of China. And of course, a lot of them, they have, for example, this one right here. Inside it has metal springs. It's like a battery box, more or less. You insert the cells and bam, you're done. While that works, you're better off if your cells are still attached like this with the strips. You're better off just gutting those springs and just wiring in a negative wire from here to your B minus, and a positive wire from here to your B plus on the circuit board and the power bank. Just a little tip there. So, again, let me just finish getting this off of here. It's still got some tape on here, of course. Although this pack was a pain in the butt to get into and get the circuit board dismantled, get the circuit board taken off of, it seems though that the rest of the disassembly is going pretty easily. And what I'll do now is I'll snip these strips to free up the cells from each other. Okay, so of course the center ones we know are bad. And of course again we'll test them. We'll just check them again to see if we get any voltage. So yeah, absolutely nothing. And again, considering we could not measure a series voltage across the entire pack, tells me that the CIDs in both of these cells have operated. So the CID, matter of fact, I have a naked Samsung cell right over here. It's a perfect example. So this is a totally naked Samsung cell. You can see it's got a little bit of corrosion on it. That's actually rust. That's just what happens when you take the wrappers off and these things sit. This is a totally dead cell. Hence why I was able to safely dismantle the I was able to take the wrapper off and the disc up here. So you got this right here. That's of course that's a vent on the positive terminal. But down below this, inside those holes, it's kind of hard to see on a Samsung cell. Let's see if I can show you another example. Okay, this Chinese knockoff cell here that you get from a generic laptop battery. So you may see inside those holes there's like a disc in there. It's like a flat surface. That is the surface of the what's called the CID, current interrupting device, and it's like a pressure plate or a pressure valve. Once the pressure inside the cell reaches a certain point, it's more or less a one-shot device. It will pop up and disconnect the cell. It disconnects the top from the rest of the cell. That way, if there's any sort of issue in the cell, like let's say if you have a short or something of that nature, something goes wrong somewhere, that CID will pop up and will interrupt any current. And it's a one-shot device. And there's also, in addition to the CID, you have what's called a PTC, or positive potential coefficient. It's like a polyfuse. What they do is they help limit current in the case of a short circuit or an overcurrent event. But of course the CID is what totally stops the cell from, or helps stop the cell from mass destructing. So the CID is that last line of defense that will operate to prevent your cell from exploding. And I've come across a couple of, I think I've come across this at least once or twice in the past, in cells with busted CIDs. So the CIDs again are definitely tripped, and these are bad cells. So these cells, I'll check the voltage again. .83 volts on this group. And 3.83, 3.82 roughly on this group. So aside from the bad cells, these seem pretty well matched. So what I'm going to go ahead and do is I'm going to go ahead and remove these strips from the pack, and these are, I have a feeling these will come off pretty easy. Because it seems like the strips on this pack are not anywhere near as big as what was on that both of the Toshiba packs. Yeah, sometimes these can be a real pain to get off, and these are coming off pretty easily. Try to get this remaining stuff off of here, but it's like, don't waste your time too much with it, because it's not the end of the world if it doesn't come off. Because what you can do, you can just smack it down with light taps of your tool. Now we're going to do the positives, and of course we'll label these. Be careful on the positive side, because sometimes if there's a breach in the cell wrap or in this protective disc, which they did, or this protective stuff they included in this pack, if there's any breach in that, I mean, this right here is actually positive. This right here is actually negative. If we reference our naked cell again, that right there, the ring on the edge, that is actually negative, and that's positive. Really close together. And that's also why cell wrap on these is so important. If that cell wrap ever gets damaged, you definitely want to prioritize replacing it. And we'll just go in and pull these off and check the tops of the cells. One thing that's really important is that you look at these over really carefully. Look at the tops real carefully. Make sure there's no foreign matter, especially metal, anywhere around here, because that could slip under this insulating washer and could potentially short the cell. So I got my collection of Sony cells that came from a Dell laptop battery pack sometime back, a little over a year ago. I was rewrapping them, and I noticed on one of them, a little bitty piece of material, looked like metal, was just sitting right between the positive and negative. It's a wonder the thing didn't short. Most likely, what would have happened is it would have tripped out the CID on the cell. And these, the CID and the PTC, those items It's not as good as having, of course, a protection circuit, but they are intended to be able to protect the cell from mass destruction with a single cell application. Now, when you have them in a pack, that's not exactly the case. So, of course, all my applications are 1S applications, or 1 series. Either they run as a single cell on my flashlight, or they run 2 in parallel in my cameras. I'm just peeling off this stuff here. Alright, go ahead and number these. I'm just going to set them to the side. I'll number them once I get these two separated. So this should be more or less the same. And with any sort of pack that has really strong strips that are spot welded really good to the cells, you have to be careful to not pull too hard, because you could actually puncture the bottom of the cell. And that could especially happen with power tool packs. Okay, so I've officially got all 4 of these cells loose. They're bare cells now. And before I wrap this up, I'm going to talk about one more thing. So these are the 2 bad cells. And if you look, you can see around here, it looks like we got some corrosion. If you think that's bad, I got a better one for you up here. Yeah, look at that. Yeah, that's corrosion there. That is what happens when these things leak. So, what I was going to say is, whenever you harvest these things, you gotta pay close attention to the cell wrapping. You can see I kind of damaged the wrapping on this cell in the process of removing the plastic. The plastic was very unforgiving, and sometimes it happens when you're tearing these things apart. You'll end up nicking up the cell wrap, and when that happens, it exposes the negative side of the cell, which is, again, from back here all the way up to here, and of course positive is right there. So let me do it again in case you didn't see. So again, you got this right here. All this is negative, and that's positive. So if you have any breaches in the cell wrap, and you have anything touching there that's part of the circuit, that could be a short, or yeah, it could also, it could complete the circuit. Let's say if it's a flashlight and your push button is back here, and the flashlight uses the casing, like a lot of my flashlights use. They use the casing as the negative side. Now in my case, my flashlights have a cylinder that slides over the cell. But let's say you have a narrow flashlight intended for just for 18650s, and that bare metal makes contact. That will complete a circuit. So you gotta be mind. You gotta in the case that you tear apart cells and tear apart packs, and you have cells with damaged wrappings, you definitely want to re-wrap the cells. It's actually really easy to do. All you need is a heat gun, or if you have a wife or a girlfriend, you can borrow a hairdryer for it as well. So yeah, what I'll do is I'll follow up with another video. I'm going to test these cells out. Hopefully these will be good. I'm telling you guys, after harvesting 4 other packs, I kind of like to find some good cells. So anyways, hope you enjoyed the video. Thanks for watching. Well, everybody, that's it for this video, but don't forget there's a lot more interesting stuff on the channel to check out. Also, if this is your first time visiting this channel, feel free to subscribe to keep your channel, and also don't forget to tick the bell so that way you'll get notified of new video posts. If you like this video, please give it a thumbs up, but if you really didn't like it, there is the alternative option available as well. Also, feel free to check out my second channel, CubeComp MTDX. There you'll find videos about bicycling, weather, elevator tours, and all sorts of other neat, interesting stuff. I hope you guys enjoyed this video. Feel free to come back, and thank you for your support.